Savonius wind turbines are a type of vertical axis wind turbine, used for converting the force of the wind into torque on a rotating shaft. The turbine consists of a number of aerofoils, but not always vertically mounted on a rotating shaft or framework, either ground-stationed or tethered in airborne systems. Origin: the Savonius wind turbine was invented by the Finnish engineer Sigurd Johannes Savonius in 1922. However, Europeans had been experimenting with curved blades on vertical wind turbines for many decades before this. The earliest mention is by the Italian Bishop of Csanad, Fausto Veranzio, who was also an engineer. He wrote in his 1616 book Machinae Novae about several vertical axis wind turbines with curved or V-shaped blades. None of his or any other earlier examples reached a state of development made by Savonius. In his Finnish biography there is mention of his intention to develop a turbine type similar to the Flettner type, but a torrotationary. He experimented with his rotor on small rowing vessels on lakes in his country. No results of his particular investigations are known, but the Magnus effect is confirmed by Car paragraph Nig. The two Savonius patents, US 1697574, filed in 1925 by Sigurd Johannes Savonius, and US 1766765, filed in 1928. Operation: the Savonius turbine is one of the simplest turbines. Aerodynamically, it is a drag-type device, consisting of 2 or 3 scoops. Looking down on the rotor from above, a 2-scoop machine would look like an S shape in cross-section. Because of the curvature, the scoops experience less drag when moving against the wind than when moving with the wind. The differential drag causes the Savonius turbine to spin. Because they are drag-type devices, Savonius turbines extract much less of the wind's power than other similarly sized lift-type turbines. Much of the swept area of a Savonius rotor may be near the ground, if it has a small mount without an extended post, making the overall energy extraction less effective due to the lower wind speeds found at lower heights. Power and rotational speed: the maximum power of a Savonius rotor is given by, where under the height and radius of the rotor and is the wind speed. The angular frequency of a rotor is given by, where is a dimensionless factor called the tip speed ratio. The range I varies within is characteristic of a specific windmill, and for a Savonius rotor I is typically around a per mil 1. For example, an oil barrel-sized Savonius rotor with H equals 7001000000000 unregistered trademark 1M and R equals 6999500000000 unregistered trademark 0.5M under a wind of V equals 7001110000000 unregistered trademark 10 meters per second, will generate a maximum power of 7002180000000 unregistered trademark 180 W and an angular speed of 69992000000 unregistered trademark 20 radians per second. Use: Savonius turbines are used whenever cost or reliability is much more important than efficiency. Most anemometers are Savonius turbines for this reason, as efficiency is irrelevant to the application of measuring wind speed. Much larger Savonius turbines have been used to generate electric power on deep water buoys, which need small amounts of power and get very little maintenance. Design is simplified because, unlike with horizontal axis wind turbines, no pointing mechanism is required to allow for shifting wind direction and the turbine is self-starting. Savonius and other vertical axis machines are good at pumping water and other high-torque, low RPM applications and are not usually connected to electric power grids. They can sometimes have long helical scoops, to give smooth torque. The most ubiquitous application of the Savonius wind turbine is the Flettner ventilator, which is commonly seen on the roofs of vans and buses and is used as a cooling device. The ventilator was developed by the German aircraft engineer Anton Flettner in the 1920s. It uses the Savonius wind turbine to drive an extractor fan. The vents are still manufactured in the UK by Flettner Ventilator Limited. Small Savonius wind turbines are sometimes seen used as advertising signs where the rotation helps to draw attention to the item advertised. They sometimes feature a simple two-frame animation. tethered airborne Savonius turbines, airborne wind turbines, kite types. When the Savonius rotor axis is set horizontally and tethered, then kitting results. There are scores of patents and products that use the net lift Magnus effect that occurs in the autorotation of the Savonius rotor. The spin may be mined for some of its energy for making noise, heat, or electricity. Gallery. References. External links. Build your own model Savonius wind turbine, Windside Savonius type wind turbines for use in extreme environments, Foldin low-power Savonius type wind turbines for marine applications, Helix wind Savonius type wind turbine, Savonius turbines for dynamic environments www.spinpower.org, How to build a Savonius wind generator, Notions of wind energy for the complete idiot.